Och de ser allt good. So now when Dan starts sharing, it will be full screen for everyone. Yeah.
Great. Hello, everyone.
Just still there.
Yeah, thanks for coming. We'll start in just a minute. If any of the presenters want to test slides or microphone really quickly, we can go ahead, but otherwise I bet they will work just fine.
I want to make sure my voice is heard.
Dan, we can hear you. That's great. Can you hear us?
Excellent. Yes. So
Good.
let me test my sharing. Hold on. I'm
Perfect.
always slow with those.
Take your
Wait a
time.
minute. Where did the sharing button go? So you see the slides?
We do.
Okay, great. So I'll just keep that up because
Yeah, you're first.
I'm the first to go.
Okay. Well, and we're just about at time. Actually, I don't see the time anymore now that we're in full screen. Well, looks like we're right at 1:30 here in Sweden, and there's no use in being tardy on the last day. We'll keep everybody on schedule. Hi, everyone. Welcome to session I3, Data Documentation and Reproducibility. We're in room G4 today, and we have 3 speakers, not 4, so they'll each have a little extra time, but we may end early. And my name is Angela Zoss. I'll be your chair today. I am from Duke University, where I work in the Assessment and User Experience Strategy Department. Very happy to be here. Without further ado, I will go ahead and introduce our first speaker, Dan Gilman. Dan Gilman is an information scientist in the Office of Surveys Methods Research at the U.S. Bureau of Labor Statistics, BLS. His research interests include metadata, standards, terminology, and transparency. He recently served on the panel on transparency and reproducibility in federal statistics, sponsored by the U.S. Committee for National Statistics under the National Academy of Sciences, for which the report was issued in November 2021. In addition, Dan has been an integral member of many and chaired several national and international standards developments efforts, especially for statistical metadata, is internal consultant to several metadata systems development projects at BLS and the Department of Labor, led the effort to build a taxonomy of terms for all BLS time series, and many others. He has presented at IASSIST conferences many times. We're so happy he can join us here today virtually. Thanks so much, Dan, and it's all yours.
Thanks, Angela. Okay, so achieving transparency in data, and I will attempt to move quickly because I have a lot of slides. So the outline is to talk a little bit about the transparency panel report that Angela mentioned, and then get into some conditions for transparency, some of which is in the report, but some also represent some work that I've been doing after the work of the panel. So the Committee on National Statistics Panel on Transparency and Reproducibility Federal Statistics that was approved in April 2019, sponsored by the National Center for Science and Engineering Statistics. There were 15 panel members from a wide variety of institutions, including me at BLS. Sorry about this. The slide advance isn't working very well. So the work of the panel, we met on periodic 2-day meetings. The first day was usually fact-finding with invited speakers, and then the second day included internal deliberations where we figured out what we wanted to say. But of course, COVID interfered with the schedule. We didn't have any face-to-face meetings after February 2020, and this slowed down the drafting of the complete document. There was a 10-member review panel that the draft report was sent to. They produced many comments, and so comment resolution was fairly time-consuming as well. The official title of the report is Transparency and Statistical Information for the National Center for Science and Engineering Statistics and all federal statistical agencies. I actually don't remember agreeing to that. It's a mouthful, but anyway, that's what it's called. It was issued last November, and the focus is on transparency rather than reproducibility. We divided the report into several sections. There's a summary, 7 chapters, 4 or 5 appendices, I forget, but 2 of them are substantive. The first 2, A and B, and they're worth looking at. The report is long, 178 pages, from the table of contents to the end of the second appendix, Appendix B. But for a quicker read and less technical, you can look at the summary and chapters 1 and 7. And all the recommendations and conclusions are in the summary, but when you see the recommendations in each of the chapters, they're better contextualized and you get a deeper understanding of what's going on. There were several decisions made in the report. All the recommendations specific to NCSES are included in Chapter 6. But importantly, we define transparency as the provision of sufficiently detailed documentation for all the processes producing official estimates. And it's important because the word transparency is used all over the place, but is very much not defined. And so I think having a definition is a really important aspect of the report. Focus then, of course, is on documentation, which implies a need for metadata. And as I said, we reduced the emphasis on reproducibility because transparency was seen as a precondition for reproducibility. So with respect to documentation, we need to be able to find, understand, and use data, methodologies, the underlying processes, designs, algorithms, code. And when we think about documentation, of course, we think about metadata. Generally, they're synonymous, but often we use the term documentation when we refer to textual explanations, and metadata is used when we mean a more formalized way of explaining things. So metadata has a little bit of a problem, and that's because if we just have textual descriptions, in a way they tell a story of whatever it is that's being described. And formal metadata attempts to do the same thing. There's information obtained from metadata, and it should be at least as informative as a textual description, but metadata can do more. And so you can easily show comparability and changes over time and across studies and surveys. But it's hard to subdivide each kind of description. If you think about describing a variable, that's pretty straightforward using metadata. But to subdivide a rationale might be a lot more difficult because rationales cover a lot of different subject areas. It's hard to know what the components of one is. So in the formal case for metadata, we, and everybody I think knows this, we have a set of descriptors for kind of objects. And we can look at simple examples, say variables and questions. And here I have a set of descriptors needed for variables. This is very simple, but I'm just trying to illustrate the idea that that we have, that we can do this for variables, and of course we can also do it for questions. And I'm not saying that this is a complete set of descriptors in either case. I'm just using this as a means for illustration. So a set of descriptors is what we call a schema, and each descriptor is an element or a schema element. And a schema is then formalized by a specific set of rules, rules about what element values should look like, relationships among the elements, and how many and whether a particular element in the schema is required. So more generally, then, a schema is a kind of a technical specification because it's technically, it's described in technical language. A schema instance, then, is a set of all values corresponding to the schema elements. And so I have an example here for variables. This would be a description of a marital status variable, the name, the universe, all adults, because I'm assuming only adults get married. Allowed values, data type, various surveys that would have that variable, what the underlying concept is. And then for question, the same kind of thing. We have the elements filled out, although I can't know what the previous question might be. So let's move then to transparency. As we saw in the description of the report, transparency depends on documentation, and this can be provided as formal metadata. What makes a variable or question transparent? There would require the necessary metadata to support the needs of whatever uses are intended. And so we need a schema, and for each variable or question, instances of those schemas that describe the particular variable or question. Then sorry. I'm having trouble navigating through here, so excuse me. So this leads then to the notion of conformance. How do we know that that an instance follows the rules in a schema? Schema is a technical specification. It contains requirements and other conditions for the instance values. And what conformance means is to satisfy all those requirements. So an instance conforms to a schema if the instance satisfies all the requirements in the schema. This doesn't say that the values are correct, only that they follow the formatting rules. It doesn't say that the elements are effective. The schema might have missing elements. The schema might have irrelevant elements. Conformance is only about requirements, which are found in the technical spec. But what does this mean for transparency? We can see that it's a necessary condition because it means that we filled out a schema properly, and if the schema is appropriate for the needs at hand, then we think we have enough metadata to be able to make whatever it is we want transparent. But is this enough? And no. And what's a reason for that? Well, how good are the metadata? So we can get into metadata quality a little bit. Does an instance value, do the instance values follow the formatting rules? Well, we've been through that. That's what we call the syntactic level. Are all the instance values true? Well, we can apply truth theory, if you will, following Tarski's notion, and and ask the question, are the values true? We can also, Tarski's statement is that something like the variable name is marital status, and that is true if and only if the name really is marital status for the variable. So, but a more fundamental question is, does the combination of the schema elements and all their values tell the right story? And this is what we call the pragmatic level for metadata quality. So we can operationalize this, and we can do this in 4 steps. The first is at the syntax level, that's conformance, and we've been through that. In the second level, we're asking the question, are the schema instance values true? And that's an application, as we said, about truth theory. But for pragmatics, we can ask the questions, well, is the combination the whole truth, and is it nothing but the truth? It's the whole truth if we haven't left anything out. And it's nothing but the truth if we don't have anything that's misleading or irrelevant. So an example of something that would be unnecessary is what's the number of letters in the name of a variable? Well, we don't need to know that to describe a variable. We can just count the number, and something irrelevant might be the current population of the United States. We don't need to know that for the description of a variable. So therefore, we see that transparency requires metadata quality. But is there something else we need? And the answer is yes. How good is the user system interface that we have? Do we have usability around the system that we have built for finding the information that we're looking for? So generally, usability is the quality of the user's experience when interacting with systems. And we have 2 main concerns for transparency. One is the interface design. Can the user make sense of what's on the screen? And then the available functions that are required, are they built into the system in a way that users can use them effectively? So user interface concerns might, in the color and the button placement and clearly stated instructions, but we also have to have the right functions. So if we want to build in discovery and understanding, we need to be able to have those functions available to us. And what that requires is that we have metadata and schemas for both the input and output in metadata. For discovery, we have both input and output because we're putting in a criteria that we want to search for and hope that the information that comes out is relevant. And then for understanding, we need the system to provide information that allows us to understand what we're looking for. So in conclusion then, transparency requires documentation, as we saw, which in the formal case is metadata, which requires schemas. We need conformance to the schema. This part of what I've talked about is all in the report, but the additional work that I've done shows that metadata quality and a usable system interface are required as well. And my final statement is that these are sufficient conditions as well. So I don't know whether there's any time for questions, but that's what I have. Thank you.
see. Yes. So the microphone's on. I think you can hear us, and we absolutely have time for questions. Does anyone in the audience want to ask a question, or anyone virtually? Okay. We have one in chat. I can read it from here. Yes. So from Bob Ray, we see in your work on this, as well as the separate task force you worked on, did you find other agencies in the USA government were more transparent?
That's a good question. There was a survey done by some of the panel members of all the federal agencies, and we found that they're pretty variable. I would rather not name names here. BLS wasn't bad. I'll say that. We provide a fair amount of information. One of the problems with the website, although it's getting a lot better than it used to, is that the way information is laid out in each of the programs is different. And so if you're trying to navigate the website, the paths that you need to take are different depending on what program you're looking for. So, and this, of course, is something that we're trying to improve. Hope that answers your question, Barbara.
Thank you. Any other questions? I want to give everyone a chance, but I actually have one. I found this this really interesting, this extension of the idea of transparency to usability. You know, naively, as someone who doesn't think of transparency too deeply, I would have thought transparency would be kind of an incentive to have a really extensive schema or have a lot of metadata elements. And in fact, what you're saying is, you know, nothing but the truth, that having too much data can be misleading. And that leads me toward kind of privacy considerations. It seems like there's implications here to sort of take a protective approach around data in addition to being transparent. And I love how those intersect. Do you see any privacy implications for this, or any, you know, protections that this affords?
Well, so we're in this talk, we're more interested in the metadata rather than data. Mm-hmm. And of course, there's all kinds of confidentiality issues, disclosure around data, but some metadata needs to be protected as well. I've been working with the consumer expenditure surveys at BLS to build a system based on DDI, and there are several processes that happen along the way in the production of our annual microdata release that we can't let people know about because they could be used to reverse engineer data. So we have to keep some of the metadata either vague or unknown because we could say too much. So the whole truth is, of course, going to be different depending on the audience and what the controls are. Sorry, but that's a really good question.
Yeah, thank you. We actually had another one come in on chat. So what did you not expect, or what surprised you the most in the findings?
Well, in the panel report, is that what you're?
That's my guess. In the panel report.
Yeah, well, I think for me at least, it was thinking about, since my expertise is in metadata, thinking about how we could really talk about metadata in a meaningful way and talk about transparency. Because when you think about transparency, it's a broad idea, and there are all kinds of situations with different information that's needed to make things transparent. So how can we put some control around that? And that was the conformance idea. It's not new to me, because I was part of a group that sort of discovered this idea when we were looking at some standardization around accessibility many years ago. And so accessibility, transparency, a number of these broad subjects that depend on metadata in some way, shape, or form, all boil down to invoking conformance one way or another to make them work.
Yeah.
And so seeing the transparency followed that, for me, was a big deal. Now, in the report in general, I think just seeing where the federal agency landscape was around transparency and the amount of work and coordination that are still before all the agencies, I think is pretty, we have a hill to climb. And we're slowly making progress, but we have a way to go.
Mm. Well, there's some reassurance in the chat that in Bob Ray's opinion, at least on the social programs, the BLS is light years ahead of the other agencies. So hopefully,
well, we do we work on it. We're trying, and we still have to improve, I think, but we are we try pretty hard.
Well, thank you very much. And thanks so much for your presentation. We're going to move on to the next presenter, but let's thank Dan again.
Thank you all.
Excellent. So our second presenter today, who is in person, is Archana Bidargaddi. Oh, sorry, switching microphones. Our second presenter today is Archana Bidargaddi. And she'll be presenting Adopting Modern Technologies and Industry Protocols to Increase Fairness of Data Archives, ESS as a Service, a Case Study. Archana is at the Norwegian Agency for Shared Services in Education and Research. She is a tech lead and IT architect with over 20 years in the IT industry. Her expertise is digitalization, innovation, design thinking, and research data. In recent years, she has led projects building technical solutions for making fair a reality, harvesting the constantly changing landscape by being agile, responsive, and open to adopting technological advancements enables making research data fair in the truest sense. Thanks so much for joining us, Archana.
Thank you for your introduction, and thanks for this opportunity to present the work we have been doing for the last 3 to 4 years. And
let's make sure we can advance your slides.
so just an introduction, the organization I work for is Sikt. Previously, it was called NSD. We recently, in Jan 2022, we merged with 2 other organizations to provide, to become the Norwegian Agency for Shared Services in Education and Research. And today's topic is adopting modern technologies and industry protocols to increase fairness of data archives. And we are talking primarily ESS as a service, a case study, but I also will talk about the Norwegian data archive we have within NSD that has benefited from the same work we have done. So I will be moving in between both ESS and the NSD data archive. And topics primarily I will be covering today is a brief introduction to ESS as service, what is ESS workflow, and the service in architecture that was to support this workflow, dissemination access solutions we have been working on, and the recommendations from our experience through this whole 3 years of working on modernizing our platform. And for those who are not aware with ESS, ESS is European Social Survey. It's an academic survey that is conducted every 2 years, started in 2001. And it's done across almost 30 countries. The number of countries change, and also the number of questions change over the years. And it's a very rigorous, high quality, qualitative data that is collected. And it's a very streamlined process. So here, why I want to specify this is already the data and the process are of very well controlled, and they are of high quality, and the metadata is also of high quality. So that's the starting point for us. And here to deviate, the other case study which I was mentioning is it's completely different, wherein we are in a data archive where we collect data after the researchers are done with their studies. So we do not have control of the metadata prior to we get the data towards us. So we have two complete different scenarios. But what we did the last 3-4 years was we were lucky to have multiple projects that were funded by different organizations to do similar kind of modernizations for these two archives, the major archives, ESS and the NSD's social science data archive. So what we did, instead of running two projects parallelly or in silos, we kind of collaborated both of the projects, and we made one big team that would work together and kind of build consolidated solutions and harmonized and homogeneous solutions to kind of break down the silos, break down the differences between the practices, and adopt similar technologies. And ESS modernization was financed by the SHOCK project, and primarily today's presentation is based on that. And meanwhile, or right after we had this funding, something happened at within our organization. We had a crisis with our infrastructure support team, and we missed 3 members, or the core members who were support for the infrastructure. And this pushed us to move from on-premise to cloud at a very crisis management speed. Often organizations take adoption of cloud as a very long process, a lot of discussion, policies, standards. But for us, it was do or die situation because we had missed people. And the complexity of our on-premise was too much to manage or kind of hire new people to do it. Hence, parallel to these 2 projects, which I mentioned, which were focused on archive modernization, we also had moving to cloud or adoption of cloud happening. And this helped us, since we were very agile, and also, as she mentioned in my introduction, very open to how we adopt technology and situations that were coming up, because our proposal, the proposal we gave and the plan we had for the product was completely different. But when the situation came and we had to have an on-cloud infrastructure, we made use of that. So we kind of moved to cloud infrastructure, started adopting technologies which were very cloud native to enable shared collaborative services, both internally for data curation, data processing, and also to build data dissemination and data analysis services. And part of the other part of these projects were also that we built a lot of solutions ourselves. That's how we started. But as we went and we said, like, no, that doesn't make sense. We have to kind of pick what exists already and use it and do what doesn't exist. So this is a constant evaluation we did. So we were not dogmatic or true to what we set out to be, except for the problem solving, which we were true to. This is the problem we want to solve, not how we solve is important. And I take this OAIS model, which everyone is aware of, where we have ingest, curation, data archival, and dissemination. And ESS workflow is also very similar to this, based on the same OAIS. And to talk in detail, I think you can't see. So what we have is we have the data ingest, where we do a lot of, do you see the pointer? Yeah. So we have the data ingest, multiple cloud-based storage systems where we get data from external deposit service, and we have integrated with our cloud storage. So there is transparency between the data depositor and the data processing team. So every change that is done to the data can be reviewed by data owners or the data, those who have deposited data. So the crux of transparency and increasing trust to the data processing methods we engage in, it was very important for us. And once we do these processing, we merge the multi-country data into one cumulated data. And then here a note would be, where does the metadata come from? Here, as I mentioned, ESS is a very well-defined, highly structured survey that happens. So the metadata is already in the system, and we use Collectica repository and designer for doing metadata editing and adding of it. So the metadata already exists in the repository. And when we get the data processing is done while matching the metadata that already exists in the repository. See, the data quality, the code lists, and the labels, all that is checked to the metadata that already has been added to the repository. So though the data and metadata live separately, by use of APIs, data processing APIs, we have been able to check the quality of data to actual metadata and do a quality control, create reports, share the reports back to the data depositors and tell them this is what you're supposed to send us. This is the mistakes, please correct and send it back to us. So the communication between the data depositor and us has become more smoother. And also they are able to see the processing scripts we have used and the reports. And once we are happy with the data, we publish it to the data storage. And here what we have is we use SPSS as the data storage format, but this is not used for dissemination purpose. This is just our source of truth. And the dissemination format which we are using is Parquet, because Parquet is very, the format, an open format that is meant that enables easy slicing and dicing of files. Data and also easily merging, sorting. So it's very quicker and faster to run queries and to do subsetting and creating new data subset files by using Parquet. The same power we wouldn't get by using CSV or SPSS. And that's why we have gone using Parquet. And then though Collectica has REST API, as a IT strategy, we have decided to have all our services and data accessed through GraphQL API. So we have an integrated GraphQL API, not just for this platform, but all services we have built. And hence we built a wrapper around the metadata API, Collectica metadata API that already exists. And this gives us the power to create very specific clients for our own needs, clients for data dissemination, metadata dissemination, search, and also analysis and visualization. And this is kind of the service architecture. I've talked most of it. I'll briefly kind of say, this is the MyESS is an external deposit service, and we would like to keep it as that because it could be MyESS. We have other data deposit portal for NST's other archive. So those we keep as outside the data platform. and open for any deposit portal as long as they send the metadata in DDI lifecycle format. And we do the ingest into Collectica repository. And also the data comes to blob storages. So we have blob storages. And we use Python as data processing for data processing. And we use Jupyter as the IDE for it. There was an option to use install IDE directly in Kubernetes and kind of run it. But again, make it lean, make it slim. So we use Azure ML, even though we don't use machine learning and the whole thing, just because out of the box, Azure ML supports Jupyter. In the same way, we have, as I mentioned, we use Collectica Designer for metadata editing and repositories for metadata storages. We use Collectica Workflow to publish metadata from processing to published repository. And we have built very tiny microservices that, like, as one of them is metadata transformer that kind of crunches the metadata in the repository to our needs. So, and also we have DOI publisher that kind of mints data DOI whenever we have published a new thing. And we are building multiple visualization and search and custom file creation clients on top of this. So briefly, I have 5 more minutes, I think. Briefly, recommendations are core of the success is the team and the approach we took. Don't be dogmatic to what you set on. Be very, be focused on solving the problem and not to a technology or how you have designed architecture. Those don't mean anything as long as your problem is solved the best and lean and cost-effective way. And API first for us, all services, internal and external and clients, they don't have the right to talk to each other at all except through API. So that's the core we have been following. And enabling metadata-driven services. All our services are metadata-driven. Data processing is metadata-driven. Our analysis, visualization, subsetting, everything is metadata-driven. And we are building custom solutions for data download, data access, and faster search. And most importantly, very important to keep the integrity of the whole system is data and metadata have to be connected. And I've talked about this. And briefly to mention the protocols which we have used, DDI lifecycle has been the backbone of this whole system. Without DDI lifecycle, we wouldn't be able to kind of build the whole machine actionable, machine-driven, metadata-driven system at all. And here we did explore in the beginning before we adopted Collectica, building our own system that was more DDI lifecycle plus, but it would be complex, it would be time consuming, there was no expertise, so we dropped that idea. But it is a goal that we adopt more metadata standards to suffice other needs. And GraphQL API, as I mentioned again, REST is fine, but we have taken GraphQL API as a standard because it is quicker. It helps mobile first development of clients. So that's the API technology we have adopted. And login, use Open ID Connect and OAuth so that users can use their login methods, be it Google, be it FIDA, or we have our user database which they can log into. And Terraform, the cloud is a big wild world, and there's again unstructured, anything is possible, you can define as how. But we have decided to have a very streamlined, very controlled information as a service and code driven infrastructure. So we use Terraform to define our infrastructure, and every database we have defined in the Azure cloud, and every service we have deployed is all driven by code and not click and pointer thing. And I have talked about Parquet, why we have chosen Parquet. It was very important for us that our analysis system and download systems are fast and also agile in a sense we could mix and match multiple files at the same time. And instead of XML, we have gone over to using JSON as the data interchange format for metadata and also when GraphQL queries come in. And a few points about metadata-driven services is versioning. I can't say more about it. Like you don't have an UUID, then your systems are not interoperable. Simple as that. So if you don't have control over versioning, if you don't have control over your IDs, then your systems are falling apart or don't do machine actionable. And one of the most important point of adopting Collectica was also that we could commission them to develop support for controlled vocabularies for us. So, and that is very important to increase the quality of metadata we have in our repositories and also to speed up curation level. So both of that, and we use SESTA controlled vocabularies, DDI controlled vocabularies, and we use ELSE thesaurus as part of it, and ISO for language and country codes. So we are using a lot of international standard controlled vocabularies to increase interoperability and connect data and metadata. This is very important. Without this, again, we cannot have metadata-driven data systems. And build solutions for download and analysis, DOI landing pages, and visualization. This is still not part of the ESS service, but it's already part of the other archive. And this is also developed by another project, but again, under the same wing. And we are building default visualizations wherein systems are smart enough to know what the data is and what visualizations make sense to show the users as they come onto these pages. So they are smart default visualization, which are metadata driven, wherein we have said they are continuous. These are the weights to use. This is your break variables, and everything is metadata driven. And Cumulative Wizard, we're building that, and it will be soon launched for ESS. This is all the 10 rounds of data would be able to merge, slice, dice, and custom create your own thing. The biggest benefit of this, is previously the cumulative data file took almost a year of manual work from our data processing team to publish. That was that much manual work needed. But now, since we have Parquet and we have built services to metadata-driven system, the moment they publish the file, it's available for being part of this cumulative file. So, and of course, and what we have achieved is cloud-based, both happy internal team, external team users, and we hope to increase use of our data and also be able to speeden the workflow and reproducibility and transparency. So thanks for your time. That's for me. Any questions?
Thank you so much. Wonderful. Any questions from the audience?
I've got several, so I'm trying to think. I'm going to focus on two. The columnar format, the Parquet format, is that? I mean, you sort of talked about speed. What are the, in a sense, it seems to me you're picking like it's columnar structures for processing, which aligns itself well with variable processing, which is kind of makes sense with ESS. Are there trade-offs for that in terms of managing records along, along the rows?
Yeah, it's possible to both, though it's columnar, it's also easier to kind of slice by row wise also. So because there's, for each type of data, it's possible to have select methods and filtering on the files. So that's why it's much faster to use case. If you want to do case subsetting, it would still be faster than SPSS or CSV. Yeah. Does that answer? Yeah.
That makes
So
sense.
it's just, though it's columnar, it's still possible to do your case subsetting, because you still take this particular variable and then you say, what is the case you want to have? And then it's filtering it out.
Yep.
So that way it's much faster. And also we use Python to work against the Parquet. So we built the survey stat engine, a microservice that does all this work. So all our analysis, download data, metadata goes through the survey stat engine microservice. Yeah.
The other question I had was just on the control vocabularies. I mean, you mentioned the CESDA, DDI, ELST. Are you managing an internal vocabulary registry, or are you actually able to point out to external services for those?
Yeah, we plan to point out, actually reference to these repositories, but there's a complexity because we cannot trust that they're always up, and also the stability and different versioning. That's why we actually import the whole vocabulary into our repository. But we know where we have imported which version, what it is, and we import the same UIDs. So then it's when we export, other archives can refer to them and use them. Yes.
Thank you. Do we have any on chat? Yes. Oh, sort of, no. Okay. Anything else?
This
Oh,
one.
yes. Sorry, I walked all the way back up here and now I'll walk back.
Thanks. Bruce from the Economic and Social Research Council in the UK. Just moving to the cloud-based solutions and architecture. Do you envisage that that is going to provide any challenges or opportunities with regards to sustainability and securing sort of long-term stability and value of ESS? And then I was interested, you know, you moved to this state because of personnel issues. And do you feel that actually your new solution is starting to address some of those risks around personnel issues? And how can you manage those better in the future?
Yeah. One of the thing is we have harmonized most of the solutions. And also, as I said, Terraform we are very strict on how we define the infrastructure. So, and also it's not single person. Most of our developers are DevOps who are in capacity to kind of manage the cloud infrastructure. And we are doing a bare minimum infrastructure, and we use observability, elastic observability, to check the quality of our cloud infrastructure. And that's why I think the infrastructure challenges are mostly addressed by moving out from on-premise. The other challenge is actually how we are going to address new projects and new developments and stuff. And since we became Sikt, we have now have a product area that's data management. And we have kind of got everything that's under data management into one IT team. And everything will be coordinated development and coordinated solutions. And the whole idea is we have a harmonized complete infrastructure, and we don't have sporadic one-off building of solution because we just had to do it. And sometimes we do have commitments to CESDA or other partners wherein we may have to take part in such one-off experimental projects that we would have to keep out of our stable infrastructure. So we do not want heterogeneous systems existing, and any further development to the system would be through a managed project. Yeah.
There is one in Zoom now. Yeah, I used to hear about the RAIRD project at Sikt. How does this fit in with your work?
Can you repeat?
RAIRD project at Sikt?
Yeah, RAIRD. Okay, it's a parallel project. Here, this whole project is for anonymized data. So it's not personal data, it's not sensitive. And that's the reason this whole architecture and this approach is. RAID is meant for highly sensitive person identifiable data. And there are two completely different architectures, two different solutions, but having the similar team. I've been part of RAID, and Arnulf, who is a product manager for microdata platform, is also an co-architect in our services. So there's a lot of IT collaboration, and we both come from Nestor background and DDI background, so we have that with us. But they're two different solutions.
Wonderful. Thank you. I think that's all we've got right now. So
Thank you so much.
Thank you so much, Archana. And we have our final speaker for today. Thanks, Joel. Hi. So we have Joel Herndon, who's going to present Data Science by Design, Building Data Science Services and Research Libraries. Joel is the director of the Center for Data and Visualization Sciences at Duke University Libraries in the USA, where he directs a library data science program, providing support for data visualization, data curation, data management, digital mapping, and computational research support. His research focuses on how universities can improve data sharing and data science initiatives through partnerships, training, infrastructure, and project support.
Good afternoon, IASSIST. Let me share my screen first, make sure
Okay.
that's coming through.
Yes, looks great.
Thanks. So this presentation is going to be a little bit of a different angle on data documentation and reproducibility. I'm going to be focusing in on the rise of data science in academia, and more specifically in research libraries. And in talking about the topic, I think we will cover a little bit about how that rise of these new forms of research are impacting kind of the instruction and helping researchers with issues of data documentation and reproducibility. But the first thing I think I would acknowledge as I start is that data science itself is a very contested term. If you do a search on the internet and try to look up a formal definition, or either kind of which areas of research are inside of the data science space, you're very likely to see a range of different definitions. This word cloud search is a good example. You see there are kind of many different research areas that are either well represented, or either you may not be seeing some of the things that you would expect. And so we do have a lot of variation as far as where individuals think data science might be, which topics are included or not included. For the purposes of the talk and some of the work and research we've been doing, we've really been drawing from a definition by a gentleman named Drew Conway, who tried to define this growing space about 10 years ago by noting there's really a new area of research, or data-driven research throughout academia, that draws on, first of all, expertise and disciplinary expertise in a wide range of topics. There isn't really a limit here. It could be in the humanities, the sciences, or the social sciences, but that expertise is being combined with computational skills, using new forms of hardware, new software programs, new programming languages, and also bringing in a little bit of knowledge about statistics, statistical modeling, algorithm design, and math, and computer science, bringing all of these areas together into new forms of research. And so we're seeing a rise of things like natural language processing, machine learning, for example, topic modeling, things in these areas that are drawing on all three of these areas. Inside of academic libraries, I think we've seen this change, or the rise of data science, in the last 10 years, mostly in three different ways. One, there's just a very large increase in access to digital data. And when I say that, I'm not just talking numeric data, but a large rise of digital material that can be systematically analyzed, whether that's text corpora, sound files, video files. All of these are really amenable to large-scale research using computational tools and open new avenues of exploration. At the same time, I think a second thing that we've seen that's really changed the data science space is that there's just been a sharp increase in analytics tools over the last 10 years as well. We've moved from a period where people were using mostly commercial software to do a lot of this work to having a large volume of open source programming languages, R and Python, as well as web-based tools. And so the barrier to entry from working inside of this space is now very low. Almost anyone can get access, many more opportunities to do this type of research. I think the third big change that we've noticed is that these changes as far as more access to data, easier access to tools, more people interested in these topics, is that this has really expanded or at least accelerated research in a lot of areas. Machine learning is one example. Some of the disciplines that have been around a long time have really taken advantage of these changes and moved forward very quickly. But we also see new areas of research. And so it's a very exciting space. Many people are interested in doing this work. But I think really what we've seen in libraries is a big question of, one, how should libraries engage inside of this space? Talking to IASSIST today, libraries have been doing data work or social science data work for a long time. But I think there's been a little bit of hesitation, or it's a little less clear about, this seems like a little bit of a different space. It's not just a social science audience. It's not just numeric data. How can libraries kind of move forward and explore this area? And so in 2018, a group of 8 of us, a lot of us IASSIST members, came together to work on an edited volume that explored how data science was increasingly becoming present in our research library space and in the universities that we work in, both in North America and Europe. And what I'd like to share today is a little bit of some of the common findings that we found, as well, or common observations that we made, as well as some of the challenges that we see moving forward inside of this space. I think the first thing is, when I went into the project as the editor of the project, I really expected to see a lot of variation as far as, depending on the institution, the kind of what the local community looked like and how data science was expressing itself. But I actually was quite surprised. Many of the challenges that we're facing both in North America and in Europe are very similar. And I believe actually a lot of the opportunities that we're seeing are very similar. Indeed, as we talked about kind of what we were in each of the institutions that are represented inside the book, there was more shared understanding of what the challenges were, but a lot of possibilities for collaboration as well. And so let me move on to kind of some of the things that we observed. I think, first of all, almost everyone, and this is pre-pandemic, I should say, agreed that one of the ways many libraries have moved forward with data science is by offering collaborative spaces, bringing together people who've got disciplinary expertise, computational expertise, as well as math and statistics skills. That tends to be not in any one individual, but requires teams of people. And libraries is a place that bring together multiple disciplines and offer spaces for multiple disciplines, or a natural home for bringing together these teams, often in ways that you wouldn't find in a single academic department. And so many of the libraries that were looking at this trend inside of their particular university, noted that the libraries were often offering spaces, whether that's a shared space just to come together and discuss research, project rooms where teams could come together and actually flesh out some of the challenges they were facing, or specialized computing spaces. We really expect this has changed a little bit with the pandemic as more people have moved online, but as we increasingly move into new phases of the pandemic, we still think there's literally a space for people to come and meet and try to work through these issues together. I think the second large area that we found that was true across many of the libraries that we talked to was that assessment is another growth area for a lot of people using data science tools in libraries. More and more libraries are currently using the data that they gather as part of their operations and the events that they hold, holding onto that data in data warehouses, and then going back and trying to analyze that information and understand what it means for their services, how they can use it to plan future events, building dashboards so that the staff themselves are aware of kind of the impact of the services they're trying to offer, the circulation of materials, things along those lines. This has really become even more important as we've seen massive changes in library services during the pandemic. It gives people a chance to kind of continuously understand, what is happening as we're having these radical changes in services that we've had to make because of pandemic challenges, and has allowed people to be a little more nimble as far as their workflows. Some places have taken this a little bit further. This is a graph from a colleague, Luis Martinez-Uribe at the Foundation Juan March in Spain. They've moved further than just describing kind of what's happening in their library. They're actually building predictive models. They, at least at his institution, are able to forecast out, predict how many people might come to an event and plan accordingly. And so there's a great deal of power in trying to utilize the data that we have available and use some of the data science tools to move that forward. I think the third area that is kind of something libraries have done for a long time, but is quite different in the data science era is consulting and instruction. Consulting is a little bit different in that we are seeing a much larger audience, at least that are interested in doing data science work in libraries, where we used to have social science data libraries that were focused very much on disciplines that were using data. We're seeing a much larger, diverse audience that's interested in using these tools, using new methodologies, to use large volumes of digital information. And the library is seen as a natural point of coming to find out more about how those tools work and how people can reach their objectives. I think kind of coming back to the theme of data documentation and reproducibility, we really are in a space where there are groups of people who are coming together looking for new norms of how do you work collaboratively on data projects? How can I work as a team to document the work that I'm doing, ensure that that research is reproducible and publish it later? These are fairly common in a lot of libraries that are trying, or support is fairly common in libraries that are trying to support data science workflows and trying to embed some of those practices into the research process and not just afterwards when the research is done. At the same time, we've really seen a sharp increase in instruction, which is once again something libraries have done for some time, but offering data science workshops that focus on data visualization, open source analytics languages like R and Python, digital mapping, workflows that look at data documentation and reproducibility. The audience is just very large at the moment for people who would like either one, to have a short form introduction to those topics so that they can assess whether they want to consider including this in their research, or two, for individuals who may not be able to take some of these research methods or either some of these tools and bring them into the curriculum that they're currently inside of at the moment. So in better words, often there's only the opportunity to take a workshop and maybe you can't take this as part of your major, or either it's not being offered as part of the course that you are pursuing. The library often fills a gap in offering some of that access. I think the other thing we noted in instruction, and this is true, I think in many places, is one comment is, well, we can't offer a lot of specialized training. We don't have the staff. Many libraries are taking advantage of collaborative strategies in this space. We have groups like the Carpentries that are training librarians in many universities across the US and Canada and elsewhere, and trying to leverage that training of a large group of individuals to kind of pool instruction. So having shared instructors that are coming in from other institutions, offering Carpentries training, a common curriculum for training these areas. These are really growth areas for exploring how you can maximize the number of people who are available for instruction and not having to do all of it on your own. I think the last thing I wanted to focus in on that seemed extremely common across institutions was a notion of trying to develop community. I think we all realized that everywhere that we were looking at this topic, that data science in itself is a fairly new concept in a lot of places, and that while there's a lot of interest, there still is a lot of need to nurture students and indeed faculty members who are interested in working in this space and provide opportunities to move forward in this area. And so for many of us, we've been very active in trying to support student groups that want to work inside of this space, trying to foster competitions, whether data science groups that come together to look at a particular data science challenge, whether that's for a weekend or for the summer, and doing things such as offering spaces, providing consulting support, judging those contests, moving in those areas. Also trying to bring in interest groups and allow presentations inside the library space for groups that want to come together and share that with the larger community. So really trying to nurture people who want to work in the space and ensure that they've got the support they need to move forward. I think that this area of community is actually something that really, starts at the local level, but overlaps considerably as you move up to the international level. We're very focused on working with people who are local in our campus research community. We're charged to do that. but we're also really looking closely at the local. We know the data community is outside of the university, and there are local community, local universities. And what we tend to find is that there's overlap. Many of those people in the local community are part of national data efforts. And indeed, as we are here with IASSIST, part of international data efforts. And there's a lot to learn from talking to each other, learning about best practices, and exchanging what we have learned in the space and trying to apply that elsewhere. So it's a very exciting time for trying to build on that and to advance work in this area. I think in closing, what I would note is, first of all, I would strongly assert that libraries have a unique value proposition for data science. We have a long time of experience doing outreach and instruction, and it works very well in this space. Many of the tools and the workflows that we're currently using for data support and have been using for many years extend very nicely into the data science space and have been very successful. And finally, as I noted at the very beginning of the presentation, data science is multidisciplinary by nature. The library's multidisciplinary perspective really lends itself well to that by not fixating too closely on any one discipline's approach to data. I think really, once again, community as we espouse in IASSIST, and community as far as how the data science community is developing is a core part of all of this and provides a lot of opportunities. And I really do think that's a strong possibility for IASSIST. So with that, I'll close and open to questions. Thank you very much.
Thanks so much, Joel. Questions? Yes.
I'd like to just expand upon, if you could expand upon assessment and how you're using library data to make predictions about, I guess, student performance. Could you talk a bit how you work with like the registrar and getting sort of administrative data to link back into the library data that you're capturing? Because I know we're trying to do it at where I'm at, and I know that that's a difficult hurdle in order to convince administrators that they should be giving that type of data over to libraries.
I don't have a general comment to make about that. My particular group at Duke University Libraries, the Center for Data and Visualization Sciences, has not been asking the registrar for those data sets, but my suspicion is that the rules and regulations vary around the world as far as the access to student data and the protections that are in place for using that data and the agreements that are needed. So I think it's probably going to vary a little bit depending on where you're based and the type of research you're doing and the type of guarantees that you have to provide in order to secure that information, is my suspicion.
Great, thanks. Anyone else? See if anything's coming in from Zoom. Oh, we do have another. There's one in Zoom. We'll do one more in the room and then we'll jump to Zoom.
So I see a question. Bob Ray is asking about library and information science schools in the US beginning to include data science classes and what advice I'd offer. I think that trying, and this may be going back a little bit, but general facility with working with data, being able to clean data and to shape it and do and to understand data quality and context. So coming back to the metadata side of things is a very good start. It's really a kind of mostly a foundational skill for any of this work, being able to assess data. Once again, data quality, being able to process data to make it more useful. That would definitely be a solid start. But I also think maybe some training on data ethics, on data, on considering some of the concepts, once again, that IASSIST is focused on about data protections, data privacy would not be remiss for information schools that are looking and work in this space. We really are in a period where, once again, there's lots of data, but I don't think we're quite yet at the spot where we've got programs in place, or at least as much attention to some of the issues, the social issues around using research data or these types of data.
Thanks. And we have one here in the room.
Hello,
So, sure, please.
Hello, Joel. This is Rob Krim from Erasmus University, Rotterdam, Netherlands. I wondered whether there are any formal curricula, data science programs within your university, and whether there's a potential conflict or problem in terms of the branding, as I know of a situation in one of our colleague universities where the library set up data science support, and the faculty was really critical about whether the library should be the place to do this type of activity and should be more faculty owned.
So I'm going to answer that question from the Duke perspective, mainly because it really does differ depending on where you are and your particular how data science is formed at your university. Duke has been more of a pluralistic, so there are multiple data science efforts happening at our university. I'll stick with the question and then come back and make a general statement. But I would say at Duke there was more of a mini experiments across the campus, both in the schools. We do have a master's in data science program that has formed a formal master's degree. But over time, we've seen a little bit more formality as far as how data science is moving forward. We have a group called the Center for Computational Thinking, which is bringing together different data science efforts on campus. And our experience has been a little different. The library has been a welcome partner. We're part of the CCT, or the Center for Computational Thinking. I think the perspective has been more that it's going to take more than any one group to try to broadly train the community, and it's likely to take many different strategies for providing that training. And so it's been more of more additive rather than a kind of a group saying, "Oh, you shouldn't be in the space." But I do understand that has not been the story at other institutions. I really think, probably a first step of thinking about the service, which I do talk about in the book as well, is trying to see kind of how data science is shaped at your university. There's some places where there is an actual, I'm thinking of Berkeley and other places, a full data science school, or either University of Virginia, Berkeley. Other places, there are academic departments that are conducting experiments. And then there are places, once again, kind of like Duke, where you see a little bit of everything. Departments, formal programs, cross-departmental initiatives, and other things. Really, a complex landscape where the library is one of many players. And really, the strategy is kind of looking at all of that and trying to figure out where can the library fit, and as you're asking, where can the library fit in a way that's constructive instead of generating conflict among those different efforts. Mm-hmm.
Great. Thanks. And I think we have one more in the chat, at least. We've got, what are the tools you recommend for data science project documentation? Thank you.
So data science project documentation, that is, once again, a large topic. I think we've been focusing quite a bit on versioning, which the last presenter was talking a bit about that as one thing we definitely try to get groups to focus on. We've been using a variety of tools, everything from Git and the web-based versions of Git. We are an the Open Science Framework member we also talk to teams about working inside of that space. Really, we're looking for ways, without naming, I've named some tools already, but looking for ways that facilitate groups working together, where they're thinking about documentation as part of their workflow, describing what they're doing, thinking about README files or something more elaborate for documenting what they're doing, and trying to make sure that the documentation process is happening during the research workflow instead of as an afterthought. I know that's a bit of a broad answer, but we're pressing kind of as far as we can on all those. I think one thing I would add to that is the strong focus on making sure that people are thinking about sharing data at the beginning of the research process, and about the repositories that are available at the end of the process, and how you link those two things together. As far as we're working on the project now, but we are thinking about what that product or either the portions are going to be that are going to be shared at the end.
Yeah, excellent. Oh, we do have another in the room question. No problem. Let's get exercise.
Bruce from the Economic and Social Research Council in the UK. So do you think that research funders should be mandating these skills as sort of core post-doctoral training in their funding? And secondly, how can we encourage our university partners to engage with the skills and experience within the data librarian field to support that development and training?
So the first question, I have not, I guess we've been very focused in the US on funder mandates for sharing data and have probably not thought as much about mandating having certain skills for doing research. And so I've not thought a lot about mandates coming, at least in the US context, from funders for developing certain skills. And I'm suspecting that that's probably not something we're going to see very soon, at least in our research context. I think more of what has happened is that the outcomes that the funders are looking for, as far as sharing research data and making things openly available, at least once again in the US context, have kind of lended themselves to a lot of these open science and data science type workflows and practices. Because one, a lot of the workflows that we're teaching in this space are open by nature, and it's fairly easy to share if that's what you intend to do. So I would be interested to see if the funders were willing to specify certain tools or get particularly specific. I think I'd also be maybe perhaps a little bit nervous about being too specific on tools or methodologies, mainly because the space is changing so rapidly. And I'm not sure, I'd be a little bit worried about how brittle some of that advice was over a longer period of time, a 5 to 10 year window. But it's definitely something we should watch. On the second training about mandating librarians having these skills, yeah, I think encouraging is probably where I would start instead of mandating. Once again, there's a lot of local process and policy that comes into play about kind of what librarians' roles might be. I think what we've seen in the book, so once again, sharing back on some of the contributors, especially Jeanette Ekstrom has a chapter in the book about practice in Denmark that is particularly interesting in this area. I think a lot of places have looked at this as an opportunity for librarians to choose to reskill or to either develop their skills as an area of interest rather than mandating in this space. And from what Jeanette is describing, that has been fairly popular. In the US context, the Carpentries, once again, a group that's come together to provide both curriculum and training with a strong focus on pedagogy, has been very popular for librarians who want to develop skills in these areas. And it's been more of a voluntary change that we've seen more than a mandated change from above. But I think we've probably seen more things about bottom up, or at least with librarians taking initiative rather than top down mandates so far.
Excellent. Anything else? I think with that, we may be at the end of our session and potentially the end of many people's IASSIST experiences, or almost. I want to thank everyone, including our two wonderful virtual presenters and our lovely in-person presenter, and everyone who was able to make it here either in person or virtually today. Thanks again for joining us, and I hope you enjoy the rest. Take care, everyone.